Ladies and gentlemen, in this video, you're going to learn how to solve absolute value word problems, inequality word problems, and also compound inequality word problems. In this example, we're going to write an absolute value equation. The words that might tell us that we need to write an absolute value equation would be maybe something looking for the highest or lowest value when it had to be within a range of something. So Sylvie is cutting ribbon for a craft she is making for the cheerleaders. Each ribbon is 15 inches long, give or take half of an inch. How long are the shortest and longest ribbons? Well, if they're all 15 inches, but they can be a half inch longer, that would make them 15 and 5/10. Or if they're a half inch shorter, that would make them 14 and 5/10. And of course, our units are inches. If we were to write an absolute value equation for this, we would say that 15 minus x, if x is the length of our ribbon, the absolute value of that is really less than or equal to a half. If we just wanted the longest and shortest ribbons, we would just say, okay, the longest one and the shortest ones would have that difference be 1/2. The reason why we take the absolute value is because the actual length of the ribbon can be longer than 15, and so this thing would be negative. Okay, in which case it would be negative 1/2. Or this could be shorter, it could be 14.5, in which case in the absolute value we would have positive 1/2. So if you take the absolute value, it allows for the actual length to be longer or shorter than this 15, and it would still equal positive 1/2. The inequality would be what we just wrote. 15 minus the actual length might not be exactly equal to 1/2, but it could be less than or equal to 1/2. And that would be our inequality for this. Let's look at another example. Diastolic blood pressure, which is that second number in your blood pressure. Okay, sorry, my phone rang and I forget exactly where I was. So that bottom number in your blood pressure is diastolic. It's considered good at 70, but can fluctuate by 10 and still be considered good. So what is the range of diastolic blood pressure readings that are considered good? Well, if you start at 70, and you were to subtract whatever that blood pressure reading is, we know that it needs to be within 10. So fluctuate means it can be higher by 10 or lower by 10. So we want for the absolute value of 70 minus our diastolic reading, our x, to be less than 10, which means we want it to be within 10. This means that I am going to take 70 minus x and say less than or equal to 10. I'm also going to take 70 minus x, I'm going to flip my sign, and I'm going to make it greater than or equal to negative 10. I am then going to solve, and I'm going to subtract 70 from both sides to get negative 60. So negative x is less than or equal to negative 60. When I multiply by negative 1, I get rid of my negative. I flip my sign, and I have 60. So x has to be greater than or equal to 60. Over here, if I subtract 70, I get negative 80. And I'm going to divide by negative 1. I'm going to flip my sign, and I'm going to get positive 80. So I can actually take both of these inequalities and rewrite them and say 60 is less than or equal to x is less than or equal to 80. Of course, you could have also gotten right to this solution if you would have just in your head thought, okay, it has to be within 10 of 70. That puts it at 60 or 80. It can be equal to 60 or 80. You could have gotten here. But I wanted to show you another way to solve in case sometime it's not so obvious. Okay, here on the Schmaltz farm, or at home on the Schmaltz farm, I never have normal-sized animals. It's crazy. My cats are always giants, and my dogs are always really small, even if I don't mean for them to be that way. My cats, they never weigh less than 15 pounds, and my dogs never weigh more than 6 pounds. It's crazy. So if x is the weight of my pet, write a compound inequality to represent its weight. So x can be a cat or a dog. It's just my pet. If my cats never weigh less than 15 pounds, that means they weigh more than or equal to 15 pounds. And if my dogs never weigh more than 6 pounds, that means they weigh less than or equal to 6 pounds. If I were to graph this, greater than or equal to 15 is here. Less than or equal to 6, oops, I should be filling that in. Less than or equal to 6 is there. So this is an or inequality. And we have that written. That's all we needed to do. Let's go on to our last example. In this example, we're going to need to write an inequality and solve it. It's going to be a compound inequality. James is buying magic cards at the game store. He wants to spend between $30 and $40. So I know he wants to spend between $30 and $40. Basic magic cards cost $2. So I'm just going to put a note here. Basic is $2. And the special ones cost $5. James buys 12 basic magic cards. How many special magic cards can he buy and still be within his budget? So I have my 12 basic cards, which cost me $24, and I want to buy special magic cards. So I'm going to put 5x, and x is going to be my number of special magic cards, or James' number of special magic cards. And we're going to go ahead and solve this by subtracting 24 in all three places. And then I'm going to go ahead and divide by 5. And when I do that, I get 1 1/5 is less than x is less than 3 1/5. So I know that James can buy between 1 1/5 and 3 1/5 magic cards. Since you can't buy parts of magic cards, I'm going to have to say that James can either buy 2 or 3 magic cards. The way I would write that in an inequality, 2, he can buy 2, so less than or equal to x, less than or equal to 3. Essentially, to be within his budget, he's got to buy more than 1 and less than 3 1/5. So 2 or 3. And that is how you would solve it. So read the questions whenever you get these problems. Figure out if they're looking for compound inequalities, absolute value equations. Look for those words like highest and lowest or range to kind of key you in on what kind of problem you should be solving. Good luck.